To briefly introduce our team, Dylan Airy is a senior at The Ohio State University majoring in biomedical engineering. Laura Farrell is a senior at Florida Gulf Coast University majoring in biomedical engineering. And Saksha Krishnan is a sophomore at The Ohio State University majoring in neuroscience. Currently, mask-making companies are focusing on a few criteria such as visual design and various sizes. However, it's clear that when masks are optional or even required, there are still those who choose to not wear one. And we found that the primary reason for this was a lack of comfort. So our team wanted to create a solution to this issue by addressing the main concern that falls under the umbrella of comfort. We conducted a Google survey with over 100 participants located in a number of states, and we found that 43.5% of our survey takers claimed that heat was the reason they choose not to wear a mask. So we focused on heat, and this led to our approach in our mask design project.
To begin this project, our team agreed on functional specifications that our mask would adhere to. We designed the mask to cover the user's mouth and nose, to attach to the user's ears, and to have a standard sizing. We measured our current mask at a standard size of 25.6 centimeters in length and 10.6 centimeters in height. We decided the mask needed to have a filter to provide increased protection from airborne particles, and we also established we wanted to include a wire around the bridge of the nose to prevent mask slippage, since our user feedback showed that was a common issue. Our main focus for this mask was to make it breathable and lightweight in order to make wearing a mask less hot, especially in the summer. We decided a non-pleated mask would be beneficial in reducing heat in the mask as well. We decided to make our prototype out of a dry fit material, as it is breathable and lightweight. Dry fit is also water resistant, which will decrease the amount of bacteria the user will come in contact with. We found a cheap substitute for dry fit made of 90% polyester and 10% spandex. The spandex component allows for a better fit to the user's face. We included a filter inside the mask, which can be removed through a slit in the top of the mask, so the filter can be replaced and the cloth could be machine washed. We chose to use elastic bands for the attachment mechanism because we felt that was the most convenient and universal method. We also included a slit in which a wire was placed at the bridge of the nose in order to prevent mask slippage.
In designing this new mask, the goal was to create something less hot that would make college students more inclined to wear it, especially during the hot months when school starts back up. However, we did not want to sacrifice the effectiveness in order to accomplish this. Because of that, we decided to include the filter to make the mask still safe and even more effective than a normal cloth mask. In the end, we hope that with masks being required on campuses across the U.S. this fall, a more comfortable mask that is still able to do its job will allow for a more enjoyable experience for students. In order to get this mask out to the public in the most convenient way, we've decided the best course of action is to mass produce and sell them online or on campuses. With the process of designing and building one, it is much easier for these to be produced and sold rather than attempting to get students to build these themselves, especially when the goal is to get as many people to wear them as possible. Hopefully, with the proper planning and resources, this mask will be available to students at a reasonable price all over the country in the coming months.